Hello, everyone. Welcome to another episode after a pretty long delay. Uh, well, yeah, I also human. I also sometimes have other things to do. And yeah, I'm really looking forward to share my experience and my thoughts about Terramate. And yeah, as usually, if you have any questions, don't hesitate to interrupt me. I'm really interested in hearing what you guys think about it, whether it makes sense, like what you uh, would like to know, please let me know. That's how it should be. Like really open. I don't like if I'm gonna to talk about stuff which is irrelevant. So yeah, your feedback is highly appreciated. So let's start. Couple things first. I want to say weekly TF Terraform weekly newsletter, which I publish every Wednesday, is growing, nicely growing, and I think now there are more than 7,000 and about 200 people subscribed. So if you want to learn more about what's going on in Terraform ecosystem, or maybe you want to read my humble opinion on some of the things, uh, subscribe, and yeah, and you will see what I find interesting. Since last time I had live stream, I released, I don't know, maybe three, four different newsletters. I like different projects in each of these. And yeah, again, if you're into security or into CI/CD, uh, into in general, like what is Terraform latest and sexiest features or sexiest project, uh, leave your email and subscribe. Let's see. Can you leave a comment just to confirm that you can hear me well? Because it's kind of important. If nobody can hear me well, then yeah, it's pretty bad. Uh, one more thing which I want to share before I go deeper into uh, Terramate today. I'd like to say that uh, Christian has adopted. Hello, Hussein. Thank you very much for confirming that. Hello, Christian. So Christian uh, is is the guy behind behind this project. So why I want to mention this one is that you probably have heard about 37 Signal, once model, where instead of buying something on subscription, you buy something like once and you use it for as long as you want. Um, you can do this, and yeah, that's what his blog post is about. He is selling Terraform building blocks, uh, mostly built on top of Terraform AWS modules. So if you are into saving some time yourself, you can buy this stuff, and yeah, you can see how it works for you. I have not been involved in development any of those projects, or I have not been using those projects myself, so I cannot actually tell that oh they're amazing or no they're terrible. So it's totally up to you. I just like that this model is applicable here, and I encourage you to check it out, maybe talk to him and see if it's for you. Okay, so let's start with something fancy, right? How fancy it should be, it's up to you. Well, raise your hand if you know what is Terragrunt. While you're raising your hand, I will check email. No, I'm joking. Of course, I know that many of you know what is Terragrunt, and you probably used it before, but you probably at some point discovered that it becomes too hard to deal with, a bunch of limitations there. You can think like, oh, it's not developing quickly or something is bad. So you obviously start to looking around and start to complain because that's the nature of human. I've been using Terragrunt myself for many, many years in many different projects, and I still use it quite actively and sometimes even happily. Uh, but from time to time, I want to see what is actually next, because there are a lot of tools which can be used on top of Terraform, and the community is not sitting on one place all the time. Um, so yeah, I discovered this one. I already made the review of this tool August last year. I will put link into description to the video. But what is actually is it possible for you to include to increase? Well, I think it's actually maximum. Hmm. Let me see. Maybe I can click somewhere here. Let's see. No, it's actually maximum. Interesting. Let me see. No, it's maximum volume. Well, I should just shout. Okay, I'm alone here, so I can shout as loud as I can. Can you hear me? Okay, good. Okay, so um, you probably have heard about OpenTofu. Maybe you even consider switching to it, and you think about like, oh, not Terraform is going to be kind of decommissioned soon, and we just need to rush and use whatever people develop or fork. I don't want to talk about this really. Uh, or you can just think critically and understand what is actually missing, right? License change, or project is not open source, or whatever else you can think about is one thing. But at the end of the day, there are tools and there are lots of approaches how you can combine these two things, right? You can have Terraform and you can still be a good citizen. You can still uh, be in good relations with HashiCorp and continue using their product and build something on top of it. Okay, and that's exactly what Terramate did. Instead of being aggressive and say like, "Oh, HashiCorp just destroyed our business," we want to continue serving customers, and we build something what is not violating license agreement or doing anything against terms of use of Terraform. So this is definitely a big, huge plus to Terramate for being really productive instead of just trying to divide community and say that they're bad, we are better. So I think this fact alone is very important to acknowledge, and that's really yeah, that's really the whole point. I really respect this behavior. I wish more companies did like this. August 2023, but yeah, that's just my thought. So let's look. Where is this? Now Crisp is in the middle of everything. Yeah, Crisp is crazy project. Okay, so let's take a look into what is Terramate before I go deeper into some of its feature. And I will also, like as I mentioned, many of us know or use Terragrunt. So during my demo and during today's stream, I will mention quite a lot of features of Terragrunt, and I will try to explain how they're different and why they're implemented differently using Terramate, or how to do something what is even not possible to do in kind of same amount of time or with same quality using Terragrunt. So stay tuned, and I'm pretty sure you will learn something, and maybe you will even use Terramate in your next project. So once more, it works with Terraform and OpenTofu, and among features which I really want everybody to know. It's not somewhere here. They have commercial offering as well, but Yeah, let's go to documentation. So among features which are there, I'd like to highlight just a couple things, like orchestration. You may think about similar to what you can do with Terragrunt, where you run different stacks or different layers, and this tool will understand the order of it and will be able to do to execute them accordingly. And the second feature is code generation. Code generation is, to my mind, by far the most advanced feature. Well, not the most advanced feature. It's by far the most required feature and the most um, required from the community. Because imagine that using this functionality, we can replace usage of different Jinja, Go template, and other tools which you usually orchestrate and kind of call differently, usually to work around limitations of Terraform. So think about that: is that we can use this functionality to generate static files uh, or to work around limitation that we cannot iterate in like by providers. So yeah, we can generate code and we can run Terraform. These two things can be executed using Terramate. While at the same time, this functionality is very new, especially TMGen has been released just literally this week, I guess, and it's still pretty buggy sometimes because you cannot use it in all places. But anyway, this functionality is very important to have. Okay, let's go to code and let's see how things work. So the documentation is pretty descriptive. You can go here, you can read, and yeah, I'm interested in just showing how this stuff work and hopefully answer some questions. So let's see, you can see my screen, right? So overall, this is going to be my plan for today. We'll see how much I will be able to cover. Uh, I mentioned about what is Terramate, right? More or less. Terramate has its own set of concepts. Some of these concepts are pretty hard to understand, or maybe naming is just wrong. Specifically, I spent a large amount of time understanding variables. There are, I think, 4 different types of variables, and all of them have different scopes and different inheritance rules, which is a little bit too convoluted and pretty hard to follow. But again, it's described, and I will try to show it in the code. Um, so hopefully you will be able to understand it after or during today's episode. So let's start with code structure, right? I mean, I have made Terramate reference architecture repository, which is in my GitHub account. And I want to, uh, again, mention how we've been doing this with Terragrunt. And in Terragrunt, typically, I have Terragrunt reference architecture, which I developed 5 years ago. It's also in my GitHub. And in Terragrunt reference architecture, I put 4 different applications. Typically, again, typically, it's one of the strategies, but typically people follow the same provider mental model uh, as in the public cloud provider. So in AWS, they separate things by regions, and then inside of regions, they have uh, some other configurations. This is how it's done in Terragrunt. Cool feature of Terramate, which I think is very important, is that uh, Terramate does not require you to structure things in any way, uh, in any specific way. Okay, so uh, in Terramate we have stacks, and we can put them in pretty much any way we want. Uh, Again, you can do exactly the same things in all other tools. I'm not trying to say that, oh, this is impossible to do in Terragrunt. Obviously, the more you work with one tool, more you understand how it can be used or misused or abused. In my case, I've been abusing Terragrunt for a pretty long time. So yeah, that's why I say that it's possible, but it's pretty hard. So with Terramate, you can structure code pretty much any way you want. You can put it in any structure, group it by AWS account, by region, by project. It does not really matter. And why it is so? Because the way how uh, Terraform state files are going to be assigned to each individual stack is, again, very flexible. You can achieve exactly the same behavior as with Terragrunt. But here, for example, we can specify, where is it? Somewhere here. Yeah, that my Terraform state files are going to be stored inside of S3 bucket, and ID of individual stack is just random things which I specify to each of this folder, each of this stack. And that's pretty much it. So all of this structure is very linear. There are a few downside of it, of course, but the point is that we can structure things the way we want, and we can easily refactor things back and forth just by dragging folders in different locations. This can be extremely useful if you try to refactor something, because normally you don't care how it is stored in Terraform state file, right? That's pretty much it. So that's one of differences. Uh, let's see what else I can show. Structures like stacks and modules may sound familiar to you from pretty much any other tool. So we have possibility to include something. Typically, we place it inside a folder called modules, but in fact, it can be anything. It can be any type of file or in any structure. When we have something inside of modules and let's say modules, Terramate, then we need to include this somewhere. So the way to include it is to have block like this, import, and we specify what kind of source we want. We specify that we want to include all TM-HCL file. These files can be can have any extension. TM is just short form for Terramate, and HCL is HCL, which is Human Configuration Language. So that's pretty much it. We import something, and then Terramate during execution will load all of these files together, merge them together, and process it. So far, I guess no rocket science. So let's take a look into next concept, which is stack. So I explained that in each of these folder we have modules. Each of these module have different files which we include. I will show this in a bit. The way where this can be included is in each stack. So each stack is specific configuration which will have to be executed. And again, remember that Terramate concept is everything around stacks. So stack is specific location or specific folder where some command can be executed. And command typically is, you can think about Terraform apply, Terraform init, and so on. But in fact, it's not just limited to that. There are many possibilities where you can execute commands like infra cost, for example, in each of these folder, or you can generate any other file. The way to do this uh, is that we run C like this, is that we simply run Terramate and then run and then something. For brevity, I will use T as alias, which T is my alias, which I use to work in each of this location. So if I use Terragrunt, then it will be using Terragrunt as prefix. If there are files tmhcl, then it's going to use Terramate HCL, not Terramate commands, or else it will be just Terraform. So if I run Terraform run, and if I specify that I want to use Terraform run and then Terraform init, for example, what's going to happen is that Terramate understand what kind of stacks it has to go through, and I will explain how does it do this. So if I now list, so I run Terramate list and run order, I can see that there are 3 stacks, and it will be executing in this order: multiple buckets, random path, and static sites. I will show each of these right now. So you can always see what exactly is going to happen. It means that you can put some automation on top of it. If I run Terraform run init, it goes in each of this folder and execute it. Another way what I can do is that I can probably run something like this. Echo, yes, something like this. So imagine that you have a list of stacks where you need to do something, and you just execute echo yes, and that's pretty much what's happening here. Funny enough, just couple minutes before stream, I realized that many years ago I made a project which is called Terrible, which is a way to use Ansible to call Terraform. And that's pretty much exactly the same inspiration as here. I had some structure of Terragrunt project, and I wanted to go in each of this folder, in each of this layers, stack, and execute something. So I was using Ansible for that. It was very ugly. Yeah, it was a lot of fun, but it was so ugly that I published it online on my GitHub account, but I would never recommend anyone using it. Instead, there are better tools like Terramate where you can do something like this. Okay, I hope I convince you to not use Terrible. Okay, so what's happening here? When I run Terraform run, I made an alias that I need to generate some files. It says nothing to do because all files are generated. And in fact, if we look into each of this folder, for example, if we look into static site, we see that there is only one file with extension tmhcl or tmgen, and that's pretty much it, right? You can look into this file. Maybe it's a bit ugly, but it's not the first one to look. Let's look into this one. This is like very simple one. So we have block stack where we define what should be the name, what should be description, and what is ID. So this ID is going to be used, at least the way I implemented it, it's going to be used inside of Terraform state. So Terraform state will be using this one. And then there is globals, which means that this is going to be available inside of Terraform file. Right, so here you can see that, okay, that's configuration for stack, but where is Terraform code, which is going to be executed in this specific case? If you look into main tf tmgen, this is the latest feature which I mentioned, which was released just this week. It's going to process this file, and it's going to execute it, and it will just remove tmgen prefix, and it will make native Terraform configuration file. Usually, I don't like to see a lot of Terraform files. So the way I configure it is that I have VS Code settings JSON, and I just explicitly hide or exclude files which start from _tf, which again, by my convention, everything what starts with underscore has been automatically generated. So I don't care about it. I never want to look it. It's going to be just polluting my my environment. And also, I don't want to see Terraform files. So once I remove these files, or I can set it to false here, it will, it will show me a lot of files. Now it's not so easy to operate, but if you are from coming from Terraform natively, you kind of get used to see a lot of mess, right? Well, sorry for you, but that's reality. In our case, if we look into random path, we have this file where I was creating random path resources, and it was executed and rendered as main TF file. You can see the Terramate generated file, do not edit, because if you edit it, it will be regenerated and all of your changes will be lost. So now if you look into length equal to, you may think like how these two appeared here. Because in template, it was using tm try and then global length and free. What it means is that you can think about this as native Terraform function, though it is not Terraform, it's Terramate, which means it will be executed earlier than that. It will be executed during execution of Terramate. So first Terramate execute, and then Terraform is executed after. So Terramate will look into, hello, Soren. Soren is actually the guy behind Terramate. So if you have any questions, don't ask me, ask him. He and his team is pretty active in Discord. So if you go to Terramate, Terramate.io website, you will see links to community, and Discord is where a bunch of people from Terramate development teams are present, and they can answer questions. So looking back into this random path, so this is one of the way how we can provide values into this Terraform configuration file, right? We can specify that we want to be able to get global length if it is present. If it's not present, then use 3. So it was present, as you can see, stack TM has global length 2. That's why it was rendered as 2. Pretty simple, right? Again, no rocket science. Terramate remote state and providers was generated as well from other places. Again, I don't think there is anything interesting to look here. So let's take a look. Let's disable just this. Let's hide all of these TF files because we don't actually need them right now. So let's take a look. What else can we do? Right. If we look into a random path has no dependencies. It's just one thing which is going to be created once, and it will create resource random path. It will store it in S3 remote state. That's it. So the way how we can read this information, think about this. We have couple stacks. One stack is generating some outputs, and then we need it to use inside of another stack. There are many different ways how we can do this. One functionality which is important to know, though it's not always required to use, is possibility to control execution flow using after and once. Though after controls the execution flow, yeah, or once. Anyway, uh, when I have this functionality inside of static site, it means that I want to include this module, which I will show in a bit, and I want to provide a bunch of different outputs. So this is one of the patterns which I want to show how to get information from this random path data source, not data source, Terraform remote state, uh, and how to put it into the bucket name. So if I look into, let's look into static site first. So inside of module static site, I will look into main TF for now, though two of these files are almost identical. So in main TF file, in main tm.hcl file, I am going to generate HCL code if global bucket is present, then it will include this code. Unfortunately, for the time being, it's not possible to use tmgen HCL files, and we need to use this generate HCL construct, which is a little bit unfortunate because it looks pretty ugly. Means I cannot use full-featured Terraform language server or Terraform plugin extension in VS Code to write this thing. But as we can see, when we render this content of the file, we refer to some features of Terramate. And the reason to do that is that we want to pass information from this place where these values were specified in stack tm.hcl into this module. So when this code will be executed, all of these values will be replaced. Like everything what starts with tm.hcl or tm will be executed, all these globals will be executed, and so on. And the same for outputs tier. So now if I run, let me just show this again. So now if I go to main TF, that's it, yeah. This is how it's executed. As you can see, I put bucket name as an output of data source. So data Terraform remote state, random path outputs ID. The way this is implemented is one of the ways. There are multiple, but this one is pretty powerful to my mind. The way how remote data source is generated is the following. It's actually very important to understand. What I'm showing now is not something what I want users or like not DevOps engineers, but really users of Terraform who don't want to know anything about internals and so on. I don't want them to know this. Why so? Because I believe that when this kind of solution is written and your users or your consumers of your solution inside of your company or organization need to understand it, then something is wrong. I believe that such solutions should be implemented and available using some sort of included library. That's again what I've been doing with Terraform AWS modules. I don't want people to know how complicated things are. I want people to be able to just use it. So this approach here is pretty flexible, but how it's written and what's going on here is not something what I want your users to be able to see and think like, oh my God, why this is so hard, so complicated? Because it is not very simple. I completely agree with you. There are a bunch of different functionality of Terramate combined just to satisfy the need. And the need is, again, we want to pass output from one location, from one stack to another stack. So how this is implemented, let me explain it from a stack point of view. In place where we want to be able to get this data source, we need to specify that this stack, which is static site, is going to have blocks to read from Terraform remote state data sources. This is going to be named, and it's located in this stack location. This can be optimized and improved. That's not the whole point. The point is that think about this as meta information. While reference itself, or what is actually the value of this bucket, it should come from this data Terraform remote state random path outputs ID. That's pretty much how I'm thinking about it, and that's pretty powerful pattern to exchange data. So then later, when this code is rendered, we can see that Terraform or Terramate was able to generate two blocks, one for data source, Terraform remote state, for this random path, which means that it will read from the location where it is specified, and it will make these variables available as locals. Let's see. Somebody from Twitch are usually so suspicious because almost exclusively people from Twitch are just spammers. But this time it's not. You could create a module that has vars for state pass and output the date remote state. Yeah, this is one of the way. Okay. Yeah, good. Good to know that audio is clear because I am very loud now. Okay, so absolutely. This way, using data source is one of multiple ways. We can use Terraform remote state as one. We can use uh, outputs from this data source stored inside of locals just for shortcuts. We can use variables. We can use default values and so on. Many different things. But yeah, I completely agree that the way um, how this is configured is not very easy to understand, and it's kind of fragile. So we can do some sort of lookup, yeah, to get rid of this one because we already know that random path is already a name of stack inside of this environment and so on. Yeah, there are a few things which I agree can be improved. Yeah, so that's pretty much it. How we can pass values between different stacks. So now if I go to this data source, this information is present inside of this output just for convenience. But in fact, inside of module, it's using this reference. And this data Terraform remote state was output or was the result of execution of this TM-HCL expression. Because if you wouldn't use this TM-HCL expression, it would treat it as a string, and that's not what you want. You get string here, but you return as HCL expression. That's pretty much what I wanted here. So this is one way how this can be implemented. Right, let's take a look into another functionality, which I think is actually quite cool. Again, as I'm saying about where is this stack? As I'm talking about this way of sharing a remote state, and there are multiple different similar approaches. Why do we need this? I remember clearly that when Terragrunt started many years ago, this was like, oh my God, we can do this natively. In Terragrunt, we don't have to use data sources to pass data between different layers. But in Terramate, we have to use one of the ways. Yeah. Okay. Functionality like after, before, once, wanted by, and so on are all instructions to emulate the same behavior of dependencies block in Terragrunt, where we control the execution flow, or we say that something has to be dependent, and so on. Yeah, that's it. And this is the same pattern as dependency in Terragrunt. Okay, let's move on further. How? Let's see. Yeah, let's do something crazy. I mean, not so crazy, but let's run something. Let's run Terraform init. I did already. So if I run Terramate run apply or Terraform apply, it goes in each of the stack and executes something. And first of all, as you can see, it plan. It shows me the plan of first stack, which is multiple buckets. So this stack, I will cancel this one because I want to explain one of multiple amazing feature of Terramate, which I think everybody, including people who support OpenTofu, will just drop OpenTofu immediately. Think about that. Well, maybe not OpenTofu immediately, but at least you will understand it pretty nicely. So think about that is that when you want to use, when you want to call one module multiple times, right? You want to make multiple buckets. Like this invocation of this code, as you can see in main tm HCL, this would create one bucket. Obviously a good solution, but for one bucket. How would we do this with multiple buckets? Well, we can write something like for each, and then we can specify how many buckets, where to get information from, and so on. And let's see. And if I go to, so this solution is actually implementing it already. So for each is available since Terraform 0.13. We can do this here. What it means is that we provide map of values, and then we include this file, and it goes through this for each global bucket and does what is necessary, because it will iterate and it will get bucket name from each key element. Very simple way, but I believe it's pretty powerful. Yeah, and now I'm showing this one, and I'm thinking, why didn't I include the code to prove even bigger point? Yeah, I don't know. Okay, so for each, we'll put information from global buckets, and it will render it. So think about all these global values is something static. So global buckets is going to be used. Where is this? Here. So just replace these values. And as you can see, this code now has no dependencies on anything unknown. This is pretty much it. The code which I wanted to show is more. Yeah, I just deleted it like half hour ago. But okay, let me just explain what is dream come true when it comes to workarounds of many Terraform limitations or Terragrunt limitations. If you know, it's pretty hard to iterate in providers, or like not in providers, but let's say module calls, and then provide different different values in providers. So think about, you have this code and you want to have providers, and then you want to specify that AWS should be this one. You can write something like this. Obviously, you need to have providers block first. But what if you want to generate many of these blocks, right? So first you need to go to providers TM file. Currently, this block is very static, but yeah, here is it. I took this from another place. You can think about this. Yeah, it's not going to work anyway now. But you can write, you can generate provider block in exactly the same way as you generate any other piece of code. So that you write generate HCL, provider AWS, parameterize some things, but then inside of here you can write alias equal and then figure out how you want it to be called. As soon as you have this provider alias available, then inside of your template, you will be able to iterate through this and generate as many files, as many blocks as necessary. This is very important functionality because previously what we have been uh, asked to do is that we always have to, like, there are many different problems with this actually. Uh, starting from starting from um, starting from the situation where you have to go across all available regions and enable the security hub, right? Or what is it? What was it name? CloudTrail, for example. So you need to go in each region and do something. The way to do this is that you need to instantiate provider, call module, and pass this as a link, as a reference, sorry, and it will be called multiple times. This is something what we normally use some sort of generator like Jinja or Go template. With Terramate, we can generate this block natively, and we just run Terraform, Terramate run, and then it will generate it and do the rest. So I find it very useful as a workaround for something what people were demanding for many years actually. And I have made a list of such like top 10 problems in Terraform, which I wanted HashiCorp to fix at some point, but apparently guys from OpenTofu claim that it's in the process of kind of in development right now. Well, we'll see, but for the time being, we can use Terramate to generate these blocks natively. So that's just amazing. Okay. So that was a way to show for each in modules. Another way how we can use for each in modules, and that's more specifically to Terraform AWS modules functionality. I can show it here. Just I think it's important to know, though you don't have to use it right away. So if I look into source code of S3 bucket module, this is it here. You can see that there is folder called wrappers. Code inside of wrappers was automatically generated, and it's automatically updating every time we do changes in the module, in the parent module. So the behavior here is similar. Instead of making a call to this module S3 bucket using for each, we can specify that we want to call wrapper and that we want to provide items. So items is going to be map of elements we want to do. This is very handy for situations where you don't want to use Terraform features or Terragrunt still doesn't support it. And that's why you use items and you pass everything you want. So yeah, the initial idea for that one was exactly to be able to manage multiple identical resources inside of Terragrunt. The same approach can be used inside of Terramate, and yeah, uh, I'm pretty sure that well, it's pretty good pattern. Yeah, otherwise I wouldn't develop it. Okay, let's see what else I have. I think looking into possibilities of how to specify globals and how to control scope of these variables is something what pretty much all developers will spend large amount of time. It's one of these complicated features of Terramate. But once you understand it, then you will have locals, globals, and lets, and all of this is kind of together. I still didn't understand it, but yeah. Okay, Ilya is asking, could you recommend Terraform books like Linux Bible? Um, well, what is it? Well, there are so many books on this subject. I don't really remember which one is like the most up to date. Um, yeah, I remember one, and all of them are having identical names like Terraform in Action, Terraform Up and Running. Yeah, Terraform Up and Running by Jim Brickman is pretty good in the sense that it was, I think, the most well accepted overall. So Terraform Up and Running. I cannot write it because I don't have access to chat from here. But yeah, Terraform Up and Running is one, and Terraform in Action, I guess, by Manning is another one. Yeah, I simply don't remember names of these books. All of them are pretty identical. Okay, so um, let me just go through some of list of my complaints and limitations which I've had with various other tools, just to explain how this can be eliminated using Terramate. Yeah, good. Thank you for asking. So one complaint which I've had um, for a pretty long time with all tools out there is verbosity of output, right? I mean, imagine that I have one stack here and it has a lot of output. Most of this output is not controlled in any way because it's coming from Terraform. But with Terragrunt, it has its own set of output. Some of this output will be in JSON, some will be in text. So it's usually very messy. If we run Terramate, we can specify pretty good way to control how we want login to be handled. So we can specify different levels, and we can specify that we want it in JSON, which means it will be eventually stored in JSON format, and we can search, we can query it. So this is very convenient way. Okay, let me do. Yeah, I wanted to run it, but for some reason I was derailed. So now if I run this Terragrunt code, I want to show how it's gonna how it's gonna to fail, I guess. No, it's not gonna to fail. Come on. And the reason why it's not gonna to fail, first of all, it creates 3 buckets in for each. Buckets names are already static, and that's pretty much what we wanted. Then it's going to execute random pad. And the reason why it's executing random pad is because random pad is specified as a dependency here, as a dependency for static side. So it has to generate random pad name first, and then it will be able to read this information using Terraform remote state when it's going to create bucket inside of static site. So that's pretty much it. So now when I have this buckets created, obviously if I run Terraform apply one more time, it will understand that there is nothing to change, and it will be just all right. So no changes in each of these 3 stacks. That's what I want. So now when I have this code executed, imagine the situation where you want to delete, right? You want to delete. How you delete it? You run destroy. And if I run destroy now, let me show how things are happening now. So if I run destroy again, it understands that it has to delete one S3 bucket first. Great, right? So it already understands that the execution should be in reverse order. So first it deletes one bucket because this bucket has nobody is dependent on this bucket. Then it understands that, okay, a random path, which was used by that bucket, is never needed. Great, so let's delete that one. And then it understands that, oh, now there are multiple buckets also not needed. So let's delete those. This functionality alone, I remember pretty clearly. I spent a lot of time with like understanding how to implement this in Terragrunt because sometimes things are not explicitly specified, uh, and you may not have the whole possibility to control whether it has to be before or after and so on. Here is very granular control, and I really like that one. So as you can see, all I have to do is just run reverse Terraform destroy, and if I want, I can run Terraform apply to create these things. Pretty straightforward so far. I explained the limitation and the workaround when it comes to creation multiple providers. So think about this as that you can create Terraform code which will create multiple copies or multiple instances of the same provider, and then you can use it in your code. Another functionality which I find very useful is the way to granular control what you want to run. So if you want to run, imagine that you have a lot of stacks, right, in different environments, and instead of going to specific and run one by one, you can specify that you want to run something like running by tags, and then you specify that you want to run dev, and you don't want to run uh, dev and what else? Dev and random path, for example. So random path, you can specify very explicitly what you want to run, and let me run it. Does it work? Yeah, it works. Okay, so it was able to understand that I want to get just this one. I can also specify that I want to have subtraction of it, and I specify null tags. So here, for example, I want to run dev, let's say all dev, but I don't want to run random path. What? Yeah, I wrote tags, null tags, random path, and it still ran it. Then I probably wrote it incorrectly. Random path. Yeah, maybe I need to run tag. No. Okay, I don't remember the syntax here, but tags dev. Uh, there was somewhere like this random no tags. Why it's executing in random tag? I explicitly want to disable it, but yeah, I don't remember why a random path. I think I need to write something like tag. No. Okay. Anyway, it is documented. Just me who's stupid here. So let's leave it like this. This functionality, by specifying tags and no tags, allows us to have the same behavior or actually not the same, but similar behavior, also very powerful, as we would have by running apply all or validate all in Terragrunt, though, yeah, similar behavior. It's very useful if you have, like in my case, I have I have GitHub Action pipeline, and I want to run things with tag dev or automatically, but things which are run prod, I want to run only a Terraform plan, for example, something like this. Okay, what else I have? Yeah, when it comes to state of this tool in general, I'd like to say that it is not, how to say, not so polished, but at the same time, it has a lot of tools, a lot of features, which I find very useful, but I just don't have enough need for that right now. One of such feature is called, let's say, experimental metadata. No, experimental. Right. So there are multiple experiments which are executed or are available there. Some of these experiments, you can see that they are here, like clone stack, or trigger. This is another useful feature, change detection. I'm not using it myself because I find it not necessary, at least for my case. Or eval if you want to evaluate some expression, but not completely, and so on. So some of these functionalities are very useful and potentially will be implemented. So if you have any questions, just reach out to anyone in Discord, and yeah, I'm pretty sure that some of this functionality will save you a lot of time. I'm personally looking forward to have significantly better support for Terraform modules. Yeah, that's just me. And yeah, let's see. Yeah, let me show what I mean by significantly better improvement to support Terraform modules, because I think it's very relevant, especially if you've been using Terraform for some time. Maybe you already see that some of these solutions are not nice because you need to do, like, personally, I find it pretty bad if users will have to write these kind of things for general things, like to instantiate providers. Well, okay, but I don't want to write this kind of code. Or like in my case, uh, here, it's okay, but it's ugly. That's the main problem. So I'm thinking maybe there will be a solution when it comes to experimental vendor manages vendor Terraform modules. Yeah, maybe that's going to help. The way I was dreaming to have this is, let me think how to put it here. So what I wanted to have, when I say that I want to create static site here, I want to include, I want to achieve exactly the same functionality as in Terragrunt, where I want to specify that I want to just use module which is inside of registry, and please pass these values to it. I don't actually want to write. In most cases, that's absolutely irrelevant. I just want to eliminate the need to write this boilerplate code. The way how I can do this, and that's one of my experiments which I which I have not finished yet. Uh, yeah, it's somewhere here. Let me explain what I do here. Stack dev external module. So, um, so the need to write this code should be eliminated, and the ideal configuration for this should look similar to this one. So of course I specify what stack, whatever I can specify here. And then I need to specify that, okay, I want to use this module, and I want to specify something like, let's call it inputs, similar as in Terragrunt. And here I want to specify bucket, and this bucket, as I showed earlier, can be something, for example, static name 123. So that's pretty much all of what I want. I don't want to write any Terraform code. I know that I can use Terragrunt for that, but I like the rest of functionality here. So the way how this can be done, and it's ugly as hell, so sorry for that, is that I can write command. Well, I can actually emulate the behavior of Terragrunt using scripting workflow functionality of Terramate. So think about this as the following: that if I run this command, take take is a command which will make directory and change it to this directory, by the way. It's pretty cool. So take to this temp location, and then Terraform init from module Terraform AWS modules S3 bucket AWS into that one, which means that if I run this command, Terraform simply download the source code of this module into this TMP S3 location. It takes some time. Of course, you can parameterize it to make it quicker. But what I want is pretty much this, right? Why there are no files? Ah, right, of course, because I hide all files. I'm funny. I thought like, oh, well, that's pretty cool module without Terraform files. Okay, so inside of TMP S3 folder, now I have the source code of the whole Terraform AWS module. And then I want, so once this is executed, again, this is something what has to be executed when we run Terraform init. So now this is executed, then I need to pass these inputs to this module. The way how this can be done is, again, by processing all these inputs and generating simple variable blocks, right? No, it's ugly as hell. Anyway, if we look into this location here, we know that there are variables which has to be specified, right? They're defined somewhere here. And what I was thinking is that we can pretty much dump all of this code either using TFRs file, which means that all values will have to be static, which is bad. Then we need to, then we need to do something. The point is that by using this small command, we will have to, we'll have to just tell which module and which inputs to pass. If this doesn't sound like the right way for you, or you think something is very smelly, you can still use, and that's pretty ugly even to think about it. You can still use Terramate in combination with Terragrunt, because Terramate does not really care what you want to orchestrate. It can be anything. Yeah, I mean, if I continue with this, I will not be surprised that in a couple days I will remove Homebrew and will use Terramate to manage my files on my computer. I don't want to do this, so but it's possible. Yeah. Okay, so I think this was it. At least I wanted to show this pattern. I find it useful, but maybe hello Umka, long time no see. Mm, yeah, I think it's useful functionality, and I'd like to continue talking to developers of Terramate to achieve this functionality. I really don't like that I need to write uh, Terraform code where most of this code is already static and, well, unnecessary. Mm, or even that I need to write my outputs. Well, just change directory into the module and do everything what is possible. It is actually quite a good experience if I look into if I look into I forgot where I wanted to something like generate module. Uh, well, it's not even generate module. It's more like prepare module, because it should be at the end of the day all not all, but okay. The way how Terragrunt started is that it was a wrapper for this command, and it was like, oh my god, that's so awesome that we can just uh, pretty much change directory into this location and run Terraform natively by providing variables there. That was very cool and very much appreciated. Now it's not so, yeah, it's not so limited, and it's much more powerful now. To retain compatibility with vanilla Terraform, but remove the need to write boilerplate code. Mm, uh, well, I don't think we need to. Mm, that's another thing really important to understand. Uh, when we work with Terramate, uh, we write a bunch of different configurations here. Then we run Terraform, no, Terramate generate, which is, in my case, it's TG, just alias to Terramate generate. And then if I go to stacks, dev, random path, so all these files here, I can just run Terraform apply. All content of these files was already prepared. So there is not much needed to kind of to have compatibility with Terraform. But yeah, I agree that it's maybe a good idea to have some sort of helper to generate module. Yeah, and just pretty convenient that you have all this code available and you run it. Most of these files were automatically generated for me. Okay, let's see what else do I have in my list of things. Right, oh yeah, I want to show how this stuff is actually working in CI/CD pipeline. Let me see. Let's see if I have this code. I'm just thinking, should I make any changes here? Just for fun. Let's say if I make change to dev2, and if I now run pre-commit hooks. Well, pre-commit hooks, they would be automatically executed anyway. This is pre-commit hooks, which I have here. This one by Mineros, who is developers of Terramate, will soon be merged with this one, the main one which we maintain. Yeah, so it will be a Terramate generate here. Now I have this file generated, and I can commit and push it. And I push it into a pull request branch. I mean, this branch has already open pull request. Let me just explain how things are configured here. No rocket science. I honestly took most of it from other projects. Very simple one. In my real projects, it's a little bit more complicated because I have to duplicate some functionality and I have to assume credentials like based on stack I'm working on. So if it is dev stack, then I need to assume it, and then I need to specify the Terramate run for this specific tags is using these credentials. If it's prod, then it's using another set of credentials. Currently, there is no behavior, no functionality, sorry, which is identical to dynamic IAM role assumption, which is amazing functionality in Terragrunt. It will happen here in Terramate as well, but not right now. So as you can see, configure AWS credentials. The code for this one has been manually executed because it's not part of Terramate. And yeah, it is somewhere here. I create ODC provider, which has to be one per account. And I create ODC role. And I give everything except deletion account, which means power user plus I am full access. That's it. And then I run Terramate run, and the way how it can handle changes, it's a bit confusing sometimes to my mind. It can understand in which stacks there were changes. So it will look into different stacks and it will understand that this stack was changed during this commit, so it will have to execute init, validate, and plan there. Sometimes it's not working exactly as you expect, so I have some time think about it and like why it's not working, what is changed, how does it think about change. Documentation explains it well, but still you need to try it 100 times before you get it up and running. So that's pretty much it here. Let me go mm, to this one. No, not to this one. To this one. Something. It says something. Why it is something? Something is broken. All right. Yeah, exactly. I knew about this one, but yeah. What it means here, it's actually quite confusing. Yeah, first of all, this one, but after it assumes credentials successfully, it runs init, and then it runs validation in all of this, and then it runs plan. The way how plan works right now, that's the same situation as with Terragrunt, where you need to write code which will have all default values present. And here, as you can see, the plan is it's planning to make name like random pet, but it's just a plan. On the next execution, it's saying like, oh, I'm gonna to read from this data source. Well, sorry, dude, but this is not there yet. This information will be populated just after. The way how this can be done, um, and yeah, I can show how it's done. Mm, how it can be done. Let me see. Where is this? This is here. Terramate date. Right. So where I'm rendering this Terraform remote state, I can specify what kind of default values I'm actually expecting. So here, when I'm rendering Terraform remote state, which by the way looks like remote state, no, remote data. When I'm rendering this code, it produced this one. There is a way to specify defaults equal and then something. So in my case, it will be ID equal something, like really empty thing. Why this is needed? Because this will tell that if this key is not present inside of this stack, then use this default value. I know that it's ugly, and I never use it in Terragrunt. I would rather have it fail, but yeah, that's another story. How this is implemented now, if I run run Terraform apply inside of this random path stack, right? Right. And now if I just no changes, right? Yeah. At least I have created this. Right. Okay. I have created this resource. So now if I go to this one, if I rerun this job, it shouldn't take a lot of time, but it should work. So yeah, there are a few things which has to be improved, and this is not the problem of Terramate as such. This is just the behavior, how Terraform works and how data sources are, yeah, doing its job. So now it will do what's necessary, and it will be able to find this information and get it done successfully. Okay, let me see. What else do I have in my list? Does anyone have any questions? Or, by the way, Sergey, thank you very much for proposing this generate module block. And yeah, if we can do something to eliminate boilerplate, it would be really good. If we can put all these generic pieces outside, like generating provider block, data sources, and so on, and maybe expose it as a includable library, that would be amazing. Then that's pretty much the direction where I would like it to go. Is that people just follow steps 1, 2, 3 and have everything. It's like so-called batteries included approach. So now if I look into this one, you can see that most recent now, and you can see that it was able to understand this is plan. I can see that my changes here. Yeah. So now if I merge this and merge, wait, I don't want to merge, I want to squash. I like squash. Yeah, that's it. Okay. If you guys want to get started with it, I recommend to look into Terramate documentation. Well, that's pretty much my traditional approach. I always read documentation, like maybe like 50% at least, understand basic concepts, and then take it from there by doing something really practical. I've been using Terramate on 2 projects, and I can see that uh, reusing most of this uh, saved a lot of time. Yeah. Okay. Mm, that's it. That's it from me. I don't have anything else. If anyone has any questions, let me know. If not, then please, mm, well, you already subscribed. I don't have to tell you, but feel free to leave your email here and you will get new things soon. That's it from me, and have a great Friday, everyone, and see you after summer break. Bye.